Today, we're going to pull back the curtain on the math that powered Google's unbelievable rise. At its heart, an algorithm is just a recipe for solving a problem. And this particular recipe took the wild, chaotic, early internet and finally gave it some order. So let's dive into the story of PageRank, an algorithm that didn't just organize the web, it basically built an empire. All right, so to really get this, we have to rewind the clock to the 1990s. The web was exploding, which was exciting, but trying to find anything useful, it was a total nightmare. Sure, search engines existed, but they'd give you back this fire hose of junk and totally irrelevant results. As one paper from the time put it so perfectly, the problem was too many low-quality matches. So this was the web's first huge crisis of trust, really. The core problem was just way too simple. Early search engines just counted how many times a keyword appeared on a page. I mean, if you wanted your page about cars to rank high, you'd just stuff the word cars on it 100 times. This made the whole system incredibly easy to cheat, and it created a web where the loudest pages won, not the best ones. There was no real way to measure quality or authority. And then, right in the middle of all this chaos, two Stanford PhD students come along with a totally radical idea. Larry Page and Sergey Brin, working on a research project they called Backrub, basically said, hey, what if we're looking at this all wrong? What if we stop looking at the words on the page and start looking at the links between the pages? And their idea, well, it was one of those things that's so simple, it's brilliant. They decided to treat every single hyperlink on the web as a vote. So if my website links to a news article, I'm basically casting a vote for that article. I'm telling the world, hey, this is important, this is trustworthy. Suddenly, the entire web wasn't just a library of documents. It was a giant continuous election. But here's where it gets really clever. They didn't just stop at counting the votes. That would have been too simple. They realized something crucial. Not all votes are created equal. I mean, a vote from a highly respected, authoritative website should count for way, way more than a vote from some random page nobody's ever heard of, right? They called their system PageRank, which, is a great pun. It's named after co-founder Larry Page, but it also ranks pages. And its logic is this amazing, kind of mind-bending circular loop. A page is important if other important pages link to it. Now that was the revolutionary part. Instead of looking at what a page said about itself, PageRank looked at what the entire web said about that page. Okay, so this is absolutely key to understanding how it works. A link's voting power depends on two big things. First, how important is the page that's doing the linking? A link from, say, a major university's website is a huge vote of confidence. But second, how many other links are on that page? If that university page links out to just one site, that site gets all its incredible voting power. But if it links out to 100 other sites, that power gets split 100 ways. It gets diluted. And right there, you hit this massive, what do we do now, chicken and egg problem. To figure out the rank of page A, you need to already know the rank of all the pages that link to it. But to figure out their ranks, you need to know the rank of the pages linking to them. It's a gigantic circular dependency across billions of pages. How on earth do you solve that? So how in the world did they solve this? I mean, it seems impossible, right? Well, they did it with a brilliant thought experiment. They turned this ridiculously complex math problem into a simple story. The story of the random surfer. Okay, picture this. There's this imaginary web surfer, and this surfer has no agenda, no thoughts. They're just clicking. They start on any random page on the web. They look at all the links on that page, pick one completely at random, and click it. Then they land on a new page, and they do the exact same thing over and over and over again, billions and billions of times. So if you let this surfer click around for like an eternity, where do they end up spending most of their time? Well, the pages they land on most often, those are, by definition, the most important pages. They're the ones with the most paths leading to them. And that was the light bulb moment. A page's rank is simply the probability that our random surfer is on that page at any given moment. It's such a beautiful, elegant model. Almost too perfect. Because, the real world is messy, and the real messy web has a few quirks that threaten to break this entire beautiful theory. So the model had two huge potential flaws. First, what happens if our surfer lands on a page with no links leading out of it? A dead end. They get stuck. The algorithm calls this a rank sink. Or, what if they get trapped in a little cul-de-sac of websites that only link to each other? They just bounce back and forth between those few pages forever and never see the rest of the web. So you've got this perfect theory on one side, where everything is nicely connected. And then you have the messy, broken reality of the actual web on the other. And because of those dead ends and loops, the random surfer gets trapped, and the whole ranking system just breaks down. The math doesn't work.
But the solution they came up with? Oh, it is just so simple, it's brilliant. One of my favorite parts of this whole story. They solved this multi-billion-dollar math problem by giving their imaginary surfer a very human trait: boredom. What if, they thought, the surfer just gets bored of clicking links? And it all came down to one single number. They introduced a variable they called the damping factor, and they set its value to 0.85. This one number would save everything.
So what does that number actually do? Well, it's pretty straightforward. It means that 85% of the time, our surfer does what they always do. They click a random link on the page. But that other 15% of the time, they get bored. They ignore all the links on the page and just teleport to a completely different random page anywhere on the entire web. And that one little trick, that 15% chance of getting bored, it solves everything. Now, if the surfer hits a dead end, they'll eventually get bored and just teleport out. If they get stuck in a loop, same thing, they'll get bored and teleport out. This simple rule guarantees that the surfer can never, ever get permanently stuck, which means the math works and you get a single, stable, fair ranking for every page on the internet. Genius! And just like that, with the math figured out, this incredible idea became the bedrock of Google. But let's talk about its legacy. How does this idea from the 90s still shape the internet we use every single day? Now, you gotta understand, PageRank was an absolute game changer for measuring one thing: authority. It gave every page an objective score for its importance. But, and this is a huge but, it was kind of dumb. It was just math. It had absolutely no idea what a page was actually about. It couldn't understand relevance or meaning at all. And this is what's so wild. Even today, PageRank, or at least the core idea of it, is still in there. It's like the foundation of a skyscraper. It provides that fundamental signal of authority. And then on top of that solid foundation, Google now layers all of its incredibly complex AI and language models, things like BERT and MUM, which are designed to actually understand language and context and what you really mean when you type something into the search bar. And that brings us to a really big question for right now, today. PageRank worked because links were a kind of human-curated vote of confidence. So in our modern internet, a world of walled-off social media platforms and AI-generated everything, what's the new vote of confidence? How do we even know what's real or important anymore? It's something to think about.